Hi, it's Miss House. In this video, I'm going to talk to you about average rate of change. For future reference, I'll just use the acronym AROC, just to save time and space. What you need to know is that the AROC is the same or is equal to the slope of a line between 2 points, also known as the secant line. So for example, let's say I have a curve and there are 2 points on this curve, and I want to know the slope of the line between those 2 points. We'll call this first point A, and the second point B. That means this has a y value of f of a, or the function's value at a, and this second point has a y value of b, f of b. Now you remember from earlier classes that the slope of a line is the second y minus the first y divided by the second x minus the first x. And we could call that y sub 2 minus y sub 1, but that just means the second y minus the first y. So here we have x1 is a and x2 is b, y1 is f of a, and y2 is f of b. So when we write the formula for average rate of change, we're going to write it using the function notation, which is going to be f of b subtract f of a divided by, or fraction bar, b minus a. So it is the exact same formula as the slope of a line. But we're looking at it between 2 points on a curve, and so we call that the average rate of change, or the slope of the secant line. So for example, consider the graph of f of x. What is the average rate of change of f of x from x1 is 0 to x2 is 4? So the first thing you want to do is record your points. So if x is 0, y is 40. 0, 40. If x is 4, y is 35. So our average rate of change is the second y, 35, minus the first y, 40, divided by the second x, 4, minus the first x, 0. So 35 subtract 40 is negative 5. 4 subtract 0 is 0. So our answer is negative 5/4. And if you remember how the slope of a line works, that would mean that you're going to go down 5 and to the right 4 between these 2 points. Now I can't see this whole thing here, but I'm going to go down 5 to the right 4. So look, that's 2, 4. So from 40 to 35 is 5, and from 0 to 4 is 4. So it's down 5 to the right 4, or negative 5/4 is our average rate of change. Example number 2. Consider the graph of f of x. Let me look at the next page to see. So we're going from x is 5 to 8. So where x is 5, that's this point, 5, 9. And where x is 8, that's the point 8, 8. So my average rate of change is the second y, 8, subtract the first y, 9, the second x, 8, subtract the first x, 5, negative 1 third. So it's down 1, so look from here to here, down 1, and to the right 3. 1, 2, 3. That's our average rate of change on this graph from x is 5 to x is 8. Example 3. Consider the graph of f of x. What is the average rate of change from x is 1 to x is 5? So x is 1, they give us the point, 1, 6. X is 5, they give us the point, 5, 10. So our average rate of change, the second y, 10, subtract the first y, 6, divided by the second x, 5, subtract the first x, 1. So it's 4 fourths, which reduces to 1. So our average rate of change here is 1. In example 4, they don't give us the graph, they give us the function. What is the average rate of change of f of x from x1 is 3 to x sub 2 is 5? Write your answers in integer or simplified fraction. So the first thing we have to do is find f of 3, and then we have to find f of 5. So f of 3 will be negative 4, since our function is negative 4x plus 2. It's negative 4 times 3 plus 2 is negative 12 plus 2 is negative 10. Now that corresponds to the point 3, negative 10. And f of 5 is negative 4 times 5 plus 2. It's going to be negative 20 plus 2 is negative 18. So that corresponds to the point 5, negative 18. Now using the function notation, f of b minus f of a over b minus a, it's exactly the same as using the slope formula. I'll just do it in this format this time. F of b is the second y, negative 18, subtract. F of a is the first y. Now be careful here. We've got to subtract a negative 10. So there's a subtraction in the formula, and we have a negative 10. So that double negative is going to make this a positive. Then for my second x minus my first x, my second x is 5, my first x is 3, and so I have negative 18 plus 10, that's negative 8, over 5 minus 3 is 2, so my average rate of change is negative 4. In the next example, they want us to go from negative 3 to 8.5 and find the average rate of change. So from negative 3 to 8.5. So f of negative 3 is 7 times negative 3 minus 8.3. Negative 21 minus 8.3 is negative 29.3. So that's my first y value, or my f of b. Then f of 8.5 is going to be 7 times 8.5, subtract 8.3. I'm going to use my calculator. That's 59.5 minus 8.3. That's 51.2. 51.2. So my average rate of change from x is negative 3 to 8.5 for f of x equals 7x minus 8.3 is going to be 51.2 subtract a negative 29.3 divided by 8.5 subtract negative 3. Again, I have double negatives. These are going to become positive, so 51.2 plus 29.3 is 80.5. And then my denominator, 8.5 plus 3 is 11.5. And notice that, let me go back to my instructions. Write your answer to the nearest hundredth. So pay attention to the instructions. We're going to round to 2 decimal places. 80.5 divided by 11.5. Oh, and this time it comes out an even 7, so there's no need to round. Example 6. What is the average rate of change from f of x, x1 is negative 4.1 to x2 is negative 1.1. Again, round to the nearest hundredth if necessary. And this time our function is a quadratic function. F of x equals negative 8x squared plus 4x plus 9. So let me demonstrate for you the kind of work you're going to need to show on a test. You're going to write f of negative 4.1 is negative 8 times negative 4.1 squared. Let me create a little more space here. Plus 4 times negative 4.1 plus 9. So I'm actually going to show what I'm doing. Now from here on out I'm going to use my calculator though. Remember TI 30 X2S is the calculator that we use on tests, and it's the one that I will use. It's got the parentheses and everything in there. So I'm going to type in negative 8 parentheses, negative 4.1 close parentheses, x square key, plus 4 parentheses, negative 4.1, plus 9, and I get negative 141.88. Nearest hundredth is 2 places. That's what it comes out to. My answer is negative 141.88. Example 7. What is the average rate of change if f of x equals from x1 of 4.6 to x2 of 7.3 for the function f of x equals 1.2x cubed minus 8.9x squared minus 7.6x plus 6.1. So I'm going to literally write on my paper f of 4.6 is 1.2 parentheses 4.6 cubed minus 8.9 parentheses 4.6 squared minus 7.6 parentheses 4.6 plus 6.1. Then I'm going to let my calculator do the work. 1.2 parentheses 4.6 close parentheses exponent key to the third Exponent key on the TI-30 is this caret key. Subtract 8.9 parentheses, 4.6 close parentheses, x square button, minus 7.6 parentheses, 4.6 close parentheses, plus 6.1. This time that comes out to negative